coming from inside the cell, from what some, well, I guess in this case it is a sarcoplasmic reticulum. But it's muscle. And right now, if you're flaccid, that's what's happening. In your corpus cavernosa and your spongiosum, the blood can't get in because you're contracted, just like when Ulysses was squeezing the balloon.
Can you repeat what calmodulin's role is?
Calmodulin activates the myosin light chain kinase. So myosin light chain kinase is a calmodulin-dependent protein kinase. Yeah, what's up?
Is that the
Sarcoplasmic reticulum, that's my squiggly. Yeah, so that's coming from internal. That's IP3 regulated calcium coming out. Yeah, what's up? What's your name?
It's Jaden.
Jade.
Is the original signal from like a G alpha Q secondary system or not?
Not yet.
Not yet.
This is just like how muscle works, kind of. All right. I'm sorry, I apologize. I'm going to have to make my cell a little bit bigger. So this don't get this confused. I'm saying that because people always get this confused. This is a myoepithelium. So these are the cells that's controlling how much blood, how much plasma can go into your corpus cavernosa or your corpus spongiosum. You think about something or somebody touches you, whatever arouses you, there's a signal in the brain regulated by oxytocin. That signal leads to a nerve that goes down your spinal cord. That nerve then, through some other neurotransmitter, activates another nerve. Until you get to a nerve here, your penis. And the neurotransmitter on that nerve, so this is myoepithelium. This is another nerve. The neurotransmitter is glutamate. And it binds to something called the NMDA, which I think stands for N-methyl aspartate receptor. Who knows what I'm talking about? Is that what it stands for? You guys must be smart.
I know the other one's AMPA.
I'm pretty sure that's what it stands for. So when glutamate binds to that receptor, I told you I'm going to take all the fun out of all this. That receptor is coupled to a calcium channel. The calcium, when glutamate binds, calcium comes in. And it binds to calmodulin. See, I told you, I'm not going to make you memorize anything. We're not going to use over and over and over and over and over again. So you'll get it once and then you'll be happy. Or you'll not get it once and then you'll be sad over and over and over and over again. In this case, the calmodulin in this neuron, so this is a peripheral nerve. This calmodulin activates something called NO synthetase. And NO synthetase takes arginine and converts it into citrulline and nitric oxide. Not the stuff you do at the frat parties. That's NO2. So this takes arginine converts it into citrulline and nitric oxide, which was literally just discovered as a hormone maybe 5 to 10 years ago, since I was a professor. Well, I've been a professor a lot longer than that, but 5 to 10 years ago. It's probably the smallest, simplest thing that anybody would call a hormone. We're not done yet. This nitric oxide goes over in a heterocrine fashion goes over into that myoepithelium, where it bonds. Am I going too fast?
Yes.
Look, you guys gotta say something. Your parents paying good money for you to listen to me talk. Make sure you're getting it. I'm good. I'm God. What's your name? Oh, you're Danny. No. Yeah, what? No.
I'm Max.
Max. Okay, Max.
So that cell with the NOS, that's a neuron?
That's a neuron. That's a neuron in your penis that's been contacted by another neuron that secreted glutamate as its neurotransmitter. Okay? So this NO binds to the iron group of guanidinylate cyclase. So it activates guanidinylate cyclase. And guanidinylate cyclase converts, sorry, you can't read that. Converts GTP into cyclic GMP. So it's just like a adenylate cyclase, except it's using guanidinylate. Yeah.
What is that? It's converting what?
GTP into cyclic GMP.
Okay, and what is that of there?
Guanidinylate cyclase, GC. Okay, let me write that down. Guanidinylate cyclase. What? I don't have room to write it down. Guanidinylate cyclase. The cyclic GMP activates something called protein kinase G. So it's just like what cyclic AMP does, right? So adenylate cyclase makes cyclic AMP, and cyclic AMP then activates PKA. In this case, it's just GTP, the cyclic GMP, activating PKG. Okay, then I'll tell you a whole bunch of stuff and we'll stop and talk. Because here's what the PKG does. One is the PKG blocks that calcium from coming in. The PKG activates a channel that starts bringing potassium in. So the cell's being hyperpolarized. Why is that important, you think? Oscar, what do you say? Just the opposite. Just the opposite. If you hyperpolarize the cell, you cannot have an action potential, and those calcium channels are voltage gated. So you bring the potassium in, you're not only blocking the calcium from coming in, this PKG, but it's blocking the cell from depolarizing. This PKG also phosphorylates and blocks myosin light chain kinase. This PKG also turns on something called myosin light chain phosphatase, which deactivates myosin. Oh. And the PKG blocks the IP3 receptor on the sarcoplasmic reticulum. You already know what the IP3 receptor is.
Can you say again what MLCP is and what it does?
Yeah, let me write it down. I'm going to erase this because we're already anti-erection. All we have left to do is jacket it, so you don't need this. So I'll go over it all again. So you're flaccid. Blood is not flowing. through the penis, or as we'll see next week, the clitoris. Because you're contracted. You're contracted because myosin is interacting with the actin. Myosin is interacting with the actin, keeping you contracted so blood doesn't want to go in there. Like when Ulysses was squeezing a balloon. Because calcium bound to calmodulin is activating the myosin light chain kinase, which is activating the myosin, which is interacting with the actin. You get some signal, I don't know, if you're looking at something you shouldn't be looking at on the internet, or whatever it is you're doing. You get some signal that causes an oxytocin as a neurotransmitter, not as a hormone, released in your brain. That sends a signal down your spinal cord. That sends another signal through a neurotransmitter to a peripheral nerve. And eventually you get to a nerve that's in your penis. That nerve is activated by glutamate through the NMDA receptor. That causes calcium to come in. I'll slow down. Calcium calmodulin then activate nitric oxide synthetase, which converts arginine into citrulline and nitric oxide. The nitric oxide then acting in a paracrine, actually a juxtacrine fashion, goes into your myoepithelium, which is being contracted. That's the normal state. That nitric oxide binds to the iron group on guanidinylate cyclase, GC. That GC generates cyclic GMP. The cyclic GMP activates PKG, protein kinase G. Protein kinase because it's a kinase, and G because it's activated by GTP instead of ATP. That PKG then does a bunch of things to stop that muscle cell from contracting. It blocks the calcium channel from external, from the outside the cell. Because you need calcium to bind to calmodulin and activate myosin light chain kinase. It blocks the IP3 receptor, so the calcium's not coming from out of the sarcoplasmic reticulum. It phosphorylates myosin light chain kinase so that it no longer works. It activates myosin light chain phosphatase, which shuts off myosin light chain kinase. Oh, and I forgot. And it opens a potassium channel that hyperpolarizes the cell that also kind of stops more calcium from coming in. Yeah, what's up?
So MLCP deactivates MLCK.
MLCP deactivates myosin light chain kinase.
MLCK.
Correct. What I'll tell you about next time is this cyclic GMP is degraded by something called phosphodiesterase. And what Viagra does is Viagra blocks the phosphodiesterase, so you accumulate cyclic GMP and you maintain an erection. It was originally discovered as a blood pressure control drug because your blood pressure in your body is regulated the same way. And all these guys are like, well, I don't know about my blood pressure, but
Sorry, does MLCP directly block myosin or just MLCK?
I think it's just MLCK.
Just MLCK, okay. Thank you.
No, sorry, it's the myosin. Sorry,
It
that's
is
correct.
myosin.
It's the myosin. Yeah, I said it wrong.
Okay.
The myosin light chain phosphatase is deactivating the myosin.
Okay.
Sorry, I said it wrong. So the myosin light chain phosphatase is deactivating the myosin. And the protein kinase G activates the myosin light chain phosphatase. Yes?
Is PKG blocking MLCK as well?
Here's what PKG does. Opening a potassium channel. so that the cell's hyperpolarized. It's shutting down extracellular calcium. It's inhibiting the IP3 receptor. It's activating myosin light chain phosphatase, and it's inhibiting myosin light chain kinase. So it's doing everything it can to stop myosin from interacting with actin and to relax the myoepithelium so that blood can flow into the corpus cavernosum, spongiosum. Yeah. Glutamate is a neurotransmitter. So the glutamate is coming from a neuron that lands on the neuron that's in your penis. So that glutamate is, that's the, I guess, the postsynaptic neuron. That the glutamate has a receptor on it, NMDA. Max.
What is that receptor called? I can't quite read it.
The what?
The receptor that receives glutamate?
NMDA, I think it stands for N-methyl-D-aspartate. NMDA. Whew.
And that has the calcium channel.
The calcium channel is this receptor regulates the influx of calcium. Am I racist?
Does NMDA directly regulate calcium, or does it activate?
I think the receptor itself is a calcium channel. Who said they knew?
Yeah, it is.
Yep, there. What's your name?
Dan.
Dan. That's not correct, blame Dan. I'm pretty sure the receptor itself is a calcium, less calcium. Alright, can I erase this? Here's what happens next. Well, so what we're going to talk about next is going to happen in the epididymis, the vas deferens, the urethra, the prostate gland, the bulbourethra gland, and the seminal vesicle. So all along the reproductive tract. Okay? So from the epididymis, through all these glands. First off, there's something called pre-ejaculate. That comes from the bulbourethral or the Cowper's glands, the same thing. And that fluid is thought to lubricate the urethra for the semen that's about to come through. There can be sperm in the pre-ejaculate. Keep that in mind. If you haven't heard it before, you've heard it here. There can be sperm in the pre-ejaculate, especially if you've ejaculated before. But typically, this is a lubricant to sort of prepare the urethra for what's about to happen. With tactile stimulation of the penis, there's a contraction that's going to come because there's a myoepithelium around all this tissue that I talked about. So there's a myoepithelium, just like I described before. And upon tactile stimulation, got to tell you one thing. Sorry. Back to erection again. Sorry, I forgot one thing. There's also a hormone called VIP. So VAP, vasoactive intestinal peptide. It was discovered, originally extracted from the intestine, and it's vasoactive. It can cause constriction of blood vessels, but it is produced locally in the corpus cavernosum and spongiosum after you get an erection. And it works through a PKA system to do the same things that PKG does. So once you get it erect, and I don't have time to now, but there's a funny description of an experiment, how they discovered this, where they had these men who volunteered to masturbate in a room, and then they stabbed them in their penis with syringes and sucked blood out of the corpus cavernosa, and discovered that this VIP was there. I don't know how anybody could masturbate and ejaculate and stuff in his penis with needles, but once you get the erection, this hormone is important for helping to maintain it. Okay, so now back to what I was saying before. Okay. With tactile stimulation, there is a release from the posterior pituitary of oxytocin. Don't get those two things confused. Oxytocin was acting as a neurotransmitter in arousal. It does not leave your brain and then circulate in your body. It does not make you fall in love, as you'll read in some popular magazines. Oxytocin as a hormone comes out of the posterior pituitary. So as you're being stimulated, there's a neural signal that's going to your brain. And that signal stimulates the release of oxytocin. Actually, initially some ADP. Oh, yeah.
The hormone, it's not like, it's a binding hormone, right? It's connected to right, oxytocin. It has a certain role in that, right? Well, that you feel connection with someone.
That's it. We'll talk about that later. So the question that's being asked, and one of the things that drives me nuts, is the role of oxytocin as a pair bonding. It has been called the love hormone. I'll actually bring it. That has nothing to do with its role in orgasm or ejaculation. So it's not like when you have an orgasm, the oxytocin that goes into your brain and makes you fall in love. What Mademoiselle and some of these other magazines cut you laugh. But there are two different things, right? So as a neurotransmitter, that compound, even though it's oxytocin, it's not leaving your brain and then circulating. The oxytocin I'm talking about now comes from the posterior pituitary, goes directly into circulation, and it binds to the epididymis, the vas deferens. You're gonna love this part. The urethra. And it binds to the myoepithelium of the vas deferens, the epididymis, the urethra. It activates a G-alpha Q, which turns on phospholipase C, which takes PIP2 and generates IP3 and diacylglycerol. Diacylglycerol brings in more calcium. The IP3 causes calcium to come out. Guess what that does? That binds to calmodulin, which activates myosin light chain kinase. So you get a wave of contractions from the epididymis all the way through the urethra. You get this wave of contractions that actually propel sperm from the epididymis, fluid from the prostate, and fluid from the seminal vesicle. I don't have to write the rest of it out. We just had it. Myosin light chain kinase activates myosin, activates actin, and you get this contraction. I have a demo, but I think I'm going to skip it today. I think you get the point. The other thing that happens, so this is in the myoepithelium. Let me do this, and then I'll repeat the whole thing. In the underlying endothelium, oxytocin binds, activates a G-alpha Q, and then it ends up activating something called cyclooxygenase. And cyclooxygenase converts a lipid. So I'm saying a lipid because I just forgot what it's called. Oh, I think it's arachidonic acid. And that creates a prostaglandin called PGF2 alpha, which then acts in a paracrine fashion through its own receptor to do the same thing as oxytocin. What you're going to see this, and I'll do the whole thing again in a second. What you're going to see that's neat about this is female orgasm works exactly the same way. Delivering the baby, exactly the same hormones, doing exact, well, maybe it's a slightly different experience, but mechanistically acting exactly the same way, and milk letdown. Exactly the same way. Same kind of contractions, same hormones, same mechanisms. So Ulysses asked me to say it again. All along the epididymis, vas deferens, and urethra, oxytocin is binding to the myoepithelium, acting through a G-alpha Q. You already know what that is. Ultimately leading to the influx of calcium, which activates calmodulin, which interacts with myosin light chain kinase in exactly the same way we just described. So now you're doing the opposite, right? To get an erection, you have to relax. To ejaculate, you have to contract. The oxytocin is also acting on the endothelium to cause prostaglandin release, which acts in a juxtacrine fashion to stimulate more contractions. Oxytocin also does some of this on the corpus cavernosa and spongiosum. What effect would that have? Coaches can't answer. What effect would that have? Makes the erection go away. That's why there's this like what's it called? The period where you can't do it again? Refractory period. Because after you ejaculate, the oxytocin is actually doing the opposite on the erectile tissue. It causes it to contract. And then all those receptors turn over. So there's a period when you can't get another erection. And that's why if you have multiple episodes of intercourse, it takes longer and longer and longer for you to ejaculate each other.
So on the endothelium, after GFQ, what is that?
Where are you looking at? So there's a arachidonic acid.
Okay.
So COX-2, cyclooxygenase, converts the arachidonic acid into prostaglandin F2 alpha, PGF2 alpha. I don't care if you, I love my steroids. I don't care if you know what the prostaglandin is. But that particular prostaglandin interacts with the myoepithelial layer through its own receptor to stimulate the same pathway as the oxytocin. So you're kind of getting a help. And in fact, what you'll see if you are delivering a baby, one of the first things they do is they put a prostaglandin cream on the cervix, and that starts the contractions before they put an oxytocin through. We're getting ahead of ourselves, right? Yeah.
Can you explain the refractory period again?
So, two things. One is, you remember how we got the erection, right? Well, now oxytocin's come along, and if you look, it's doing exactly the opposite of what the nitric oxide and everything was trying to do. So one, after you ejaculate, you're going to lose the erection because now you've got these contractions in the same tissue that you were trying to relax before. Right? So there's a period of time when you can't, it takes longer to get another erection. But the other thing that happens is after you ejaculate, all those receptors turn over. Right? So there's an extended period of time where you have to wait for receptors to return to the surface before you can start over again. Any other, yeah?
So, theoretically, it might be possible that you have very low levels of the vasoactive intestinal peptide that you have almost in a very period, or really short ones, or not.
I've never heard that. And I don't think that, I'm almost sure that VIP cannot induce an erection. It's that, like, once the corpus cavernosa fills up, then the VIP is released locally. I don't think it, without, those other things happening, you can't induce an erection just with VIP. I'm like 98% sure that that's the case. What else? Yeah. Maggie. PGF2 alpha is prostaglandin F2 alpha. Again, I don't care. Just know it's a prostaglandin. But it's a very short-lived, you can imagine why, right? You don't want contractions all over your body. So it's a very short-lived and very short travel, so it's acting in a juxtacrine position. Juxtacrine fashion on this neighboring tissue. So it's, if you imagine this is the vas deferens, the oxytocin is causing contraction here. The oxytocin in this tissue is causing the release of prostaglandin, which causes more contraction. Yeah.
How does VIP help maintain the erection?
So so once you get an erection, the expansion of the corpus cavernosa and spongiosum somehow stimulate the local release of VIP, so it doesn't circulate. And what it does is it binds its own receptor, and it acts through a G stimulatory protein through PKA, but that PKA pathway does the same thing as PKG. So it's using a different pathway to do all the same stuff that PKG does to maintain the erection. It doesn't just happen that you release VIP and get like a spontaneous erection. But once you get the erection, it's there to assist. So I guess you don't continually need the neuronal signal once you actually get the erection. For the backup, I guess. Yep.
Are we going to talk about during puberty when there's relaxation without like arousal or anything like that?
We will get to puberty, yes. We'll talk all about that stuff. We gotta get pregnant and have a baby first. So that's where this part of the course will go. We're gonna get pregnant, we're gonna go all the way through pregnancy, we're gonna have a baby, we're gonna grow up, and then we'll end up right back where we started, reproductively mature, male and female. What else? We got 2 minutes. Good? All right, you guys, hey, so a couple things. If you guys want extra office hours, you have to email me. Right now it's 8:30 to 9:30. And for those of you who keep calling me Professor Hades, that's a title that I earned. My mama named me Tyrone, so show her first love. My name is Tyrone, unless that particularly bothers you. Other questions or comments? Yeah.
There's discussion.
Yes, there's discussion. I believe you're getting your exams back tomorrow. And also when you guys email me, IB137. That's all the subject. Don't write anything else. IB137. So there's discussion tomorrow. You'll probably get your exams back. And bad news is, hold on 1 second. You'll get all the detailed statistics tomorrow. The bad news is nobody got 100. The highest score was 188. So that means, huh? That's after the 10 points. So that means I owe you 12 points. So whatever score you're getting tomorrow, Tyrone owes you 12 points. It's going to be added on top of everybody's score. So if nobody got 100%, I didn't teach 100%.